Okay, lesson 12, we're working on key features of quadratic equations that are in vertex form. Last week we worked on standard form. This is in vertex form now. So you need to be able to identify key features of a parabola given in vertex form, and then talk about what those key features tell you about a graph. And on our next lesson, in lesson 13, we're actually going to be graphing these. So we're working on today getting all the information that we would need in order to sketch the graph. So this is what vertex form looks like. A is the same that A was when we did standard form. So A tells you which direction it opens. If opens up when A is positive, it opens down when A is negative. But also, this is absolute value right here. The larger the absolute value of A is, the taller and skinnier the parabola gets. So if A is 2, that means that the parabola is going to be twice as tall. So when we're in class, I usually use like a piece of silly putty and I draw a picture on it and then I stretch it. What happens if I took you and stretched you so that you were twice as tall? You would get tall and you would get skinnier, right? If A is 3, I would stretch you 3 times as tall, so you would get taller and skinnier. So the larger the absolute value of A is, the taller and skinnier it is. If A were a fraction, like a half or a third, or a decimal less than 1, anything where the absolute value is less than 1, then that means that it's getting squished. It's called a vertical compression. And it's like if I could push you down, right? If I could compress or push you down. So if it was a half, you'd be half as tall. You'd get shorter and wider. The axis of symmetry, remember we had to write that equation for the axis that cuts down the middle, is x equals h. So it's super important to remember that the number that you use for h is going to be the opposite of the sign in here because there's a negative or an opposite sign in the equation. So if you had like 2 times x minus 4 squared plus 5, here's your x minus h. So your h is just 4. The minus is already there in the equation. So h is the opposite of the sign in parentheses. Because it has that opposite sign in there. It has that negative in there. The vertex of your parabola, so this is one of the things that's really great about vertex form. It's great for graphing, is that you don't have to go through all the work we did last time to find the vertex. The vertex is just h, k. So we're going to go through practicing using vertex form, finding all the things, matching the graph, and then converting back and forth between standard and vertex form. So example 1 says find the axis of symmetry, the vertex, in which direction the graph opens. So to figure out which direction the graph opens, this is our A right here. And since A is negative, the graph opens down. I'm going to rewrite the equation since you can't see it now. Our axis of Our axis of symmetry, that's plus k. Our axis of symmetry is x equals h. H is the number that's inside the parentheses with x. And it says it's opposite of the sign in parentheses. So our axis of symmetry, remember that it needs to be an equation of a line, x equals. And then h is the number that's inside the parentheses with the x, opposite of the sign. So if this is x minus 4, then h is positive 4. And then the vertex is at h, k. So h and k. And these were made up. Sorry, I can't write and talk at the same time. This form was done so that we could find the vertex and then the h is the negative 3. And there is a really cool way to find it, which is called completing the square, which is awesome, but we are not this year going to have time to do that. So we're going to do it a little bit different way. I'd show you how to come up with it. But in this equation is the vertex and your A. Instead of having an A, B, C, we still have A. It's the same number A, but then we have the vertex H and K. So this example 2 says, which of the equations represents the graph shown? So we need to figure out which direction it opens, right? It opens down. So what does that tell us? Since it opens down, that tells us that the A is negative. So it has to be either this one or this one. These two are both out because their A's are not negative. So we've narrowed it down to these two. Then we're going to look at our vertex right here. Our vertex is 5, 3. So 5 is H, 3 is K, because our vertex is HK. So if we plug those into this equation, y equals, it opens down so it's negative. We're not going to worry for right now about why it's 3. These both have 3. They're the same. So x minus h, what's our h? H is 5 squared plus k, and k is 3. So it's minus 5 plus 3. So the correct one is B. Example 3, convert the quadratic equation from vertex form to standard form. So to do that, we need to multiply it all out and then combine like terms. We have an x minus 1 quantity squared. Squared means that you're multiplying 2 of those. So I'm going to write it out as, instead of x plus 1 squared, I'm going to write out 2 of them. X plus 1, x plus 1, plus 7. So these two are equivalent. Just instead of writing x plus 1 squared, I wrote out 2 of them. We have to distribute this now, which is actually part of our next lesson or our next unit. We're going to be working with polynomials, but I know you can do this part. So we have x times x is x squared. X times 1 is x. 1 times x is x. And then 1 times 1 is 1. Plus 7. So we're going to simplify this. In the parentheses, we'll simplify that. X squared, add those two x's together, that's 2x plus 1 plus 7. Then we need to distribute this 8 through to those parentheses. So I'm going to come over here. 8x squared plus 8 times 2 is 16x. 8 times 1 is 8 plus 7. And then our last step is we're just going to combine those last two. So we'll add the 8 and the 7. So there's no formulas for this one. You're just multiplying it out. So the key right here is to remember to write this out as 2 of them. Do not just distribute the squared through. Don't just write x squared plus 1. You have to write out 2 of them and distribute. For example 4, now we're going to go the other way. So now I have one that is in standard form, and I'm going to convert it into vertex form. So I wrote a little hint down here. What three things do we need to know to write the equation of a quadratic in vertex form? So if we come back up here, what 3 things did we need to write the equation of a quadratic in vertex form? We needed to know what A was, right? We need A. Well, A is the same as A is here. If I have it in standard form, remember that it goes A, B, C. A is the same as A. So A is 2. Then we need to know H. So we need to figure out a way to find h. Well, if we think back to standard form, we have an equation to find h because h is the x-coordinate of the vertex. And how did we find the x-coordinate of the vertex? We had an equation for that. H equals negative b over 2a. Remember when we found the vertex when it was in standard form? Negative b over 2a. So we're going to use that for this. So negative 12 divided by 2 times a. That becomes positive 12 divided by 4 is 3. So h is 3. Okay, so now we have a. Now we have h. We got one last thing to find. We need to find k. And what is k? K is the y-coordinate. Of the vertex. I know it's weird that they throw in 2 new variables, but you can't leave x and y because we already had an x and y in there. You don't want b and c because b and c are something else. So I'm not sure why h and k. There's probably a reason, but I don't know it. Okay, so k is the y-coordinate of the vertex. How do we find a y-coordinate? Well, we have an x-coordinate right here, right? If we have an x-coordinate of a vertex, 3, how did we find the y-coordinate? We found it by substituting that back into the equation. So I'm going to substitute that 3 back into the equation. That was a minus. So we get 9, 18 minus 36 plus 16. 34 minus 36 is negative 2. So 3 is our h and negative 2 is our k. So we have all 3 of those things that we need now. We found a, we found h, we found k. We can substitute them back into the equation to come up with the vertex form. So y equals a is 2 times x minus h is 3, squared plus k is negative 2. So I'm going to change that to minus. So if we graphed these in Desmos or something, this equation and this equation, they're the exact same formula. They're the same parabola. They're just different forms of the equation. So this we have standard form, which is great for some things. When we start doing word problems, it shows us that this parabola has a y-intercept of 16. It shows us that it opens up. It tells us that it's skinny. This one, if you notice, doesn't have our y-intercept in it. Like we can't tell the y-intercept just by looking at this one, but we can tell the vertex and we can't on this one. So they both have their advantages. Our last example is we're going to find all of the key features. So these should look familiar. These are the same ones that you did before. Find all of the key features for that parabola. Now here's the thing. Before we had to do some work to find the axis and we had to do some work to find the vertex. Now we don't. They're just there. But we now have to do some work to find the y-intercept, which we didn't before. So kind of a trade-off. So this graph opens, a is negative, right? So it opens down. Our axis of symmetry, if we go all the way back up to the top of our notes, the axis of symmetry was x equals h. And remember that h is the number inside opposite of the sign. So x equals positive 5. The vertex is hk. So h is opposite of the number inside the parentheses, so positive 5. Our k is the number added or subtracted to the end, 8. So just like we did before, I'm going to kind of graph a sketch. So 5, 8, say is right there, and we know it opens down. Just to help us answer some of the other questions. So this graph, since it opens down, it has a maximum. And that maximum, what is that highest point? That highest point was up here at 8. Okay, so the roots and the y-intercept, this is where our work comes in. Remember that roots are like your x-intercept. So to find that, and you can put some notes over here on the side if you want to remind yourself. To find the x-intercept, we set it equal to 0. We put 0 in for y. Do it over here. We put 0 in for y. Now, you could change it into standard form, the way we did that previous problem where we multiplied it all out, and then factor it or use quadratic formula, but I'm going to show you a different way. Okay. We only have one x here, and I want to solve for that x. So I'm going to just solve it like an algebraic equation. So I'm going to move the 8 over by subtracting 8 from both sides. That's a minus. Then I'm going to divide both sides by -2. -8 divided by -2 is 4. And then we have a square root that we don't want, right? We want to solve for x. We need to get rid of that. Sorry, I said square root. We have a square that we want to get rid of so that we can solve for x. The opposite of squaring something is a square root. So if I take the square root of this side, then I have to balance it by doing it to the other side. Square roots and squares are their inverses, so they cancel each other out. Taking a square root undoes a square. So those cancel each other out. And I just have x minus 5, which is looking better and better. On this side, if I take the square root of 4, I get 2, but I also could get -2. If I square -2, I get 4 also. So anytime you add in a radical that was not there, there were no square roots in this, right? We put them there so that we could solve. Anytime you do that, you need positive or negative. You need 2 answers. So now we're going to add 5. I'm going to write these out as 2 separate ones. So we get 2 equals x minus 5, and -2 equals x minus 5 to solve both of them. So for this one, if I add 5, I get x equals 7. And on this one, if I add 5 to both sides, I get x equals 3. So my 2 roots are 7, 0, and 3, 0. To find my y-intercept, so I have to do a little more work. Before it was just c, but we don't have a c in here now. There's no c. There was a, h, and k, no c. So to find the y-intercept, we put 0 in for x and solve for y. So for x-intercepts, we put 0 in for the y. To find a y-intercept, we put 0 in for x. And I said it, but I didn't do it. 0 in for x. So 0 minus 5 is -5. -5 squared is 25. That's -50 plus 8. -50 plus 8 is -42. So it wouldn't cross that y-axis until way down here at -42. Domain and range have not changed at all. So domain is -infinity to infinity. And the range, it opens down. So the lowest it goes is negative infinity. And the highest it reaches was up here. Do you remember how high that was? That vertex was at 5, 8. So the highest this graph goes is positive 8 with a bracket. Infinity has to get round because it's not actually a number, but 8 is. So 8 gets a bracket.